Hi guys, I'm Mrs. M and today we are going to discuss the gas laws part 3, Lussacs Law. And the source for this video is from the textbook Chemistry by Pearson Publications. Next we move on to the Lussacs Law. Lussac is a French chemist who discovered the relationship between the pressure and temperature of the gas. If we go for Lussacs law explanation, this deals with the pressure and temperature. So, if there is a constant volume and a fixed given mass of gas is there, then the pressure of that gas is directly proportional to its Kelvin temperature. That means if the P value increases, then T also increases. So, P is directly proportional to T. If you write that mathematically, then P over T is equal to K, that is constant. But remember, here volume and mass are always maintained constant. The equation for the Gay-Lussac's law is represented as P1 by T1 is equal to P2 by T2, where P1 and T1 are initial pressure and temperatures, and P2 and T2 are final pressure and temperatures. Let's discuss in detail the Gay-Lussac's law. Let's take a scenario here. A gas before it was 300 Kelvin temperature and 100 kilopascal pressure. Assume that we have increased the temperature to 600 K, that means almost we doubled. Then even the pressure also become doubled, 100 to 200 kilopascal. The reason behind here is as we increase the temperature, then the gas particles, they move much faster and they collide with each other and to the wall of the container with greater speed. Hence, the pressure inside will be much more greater compared to the initial pressure. So if you put the data of this one into this Gay-Lussac's one, P1 by T1, that is initial pressure and temperature, which is constant. So if you see that one, that is 100 kilopascal over 300. Then if you see the second one, P2 by T2, final pressure and temperature, 200 kilopascal by 600 Kelvin. So if you see this also 1 by 3 and this also 1 by 3, so that indicates that if you join both the equations, P1 by T1 is equal to P2 by T2. So if you make a graphical representation of the Gay-Lussac's law, it is somewhat like a straight line, you can see in the picture. So this graph is made by taking the temperature on the x-axis and pressure on the y-axis. So generally the thing you should never forget is temperature is always in Kelvin scale. So your task now is whether this graph does it follow the Gay-Lussac's law. So take any of the 2 points for the pressure and temperature and see whether it follows the Gay-Lussac's law. The best example for the Gay-Lussac's law is applications involved in the pressure cooker. We all know that food cooks faster in the pressure cooker than in an ordinary pot. The reason behind here is the trapped steam that is inside the pressure cooker becomes hotter, almost like 125 degrees Celsius inside than under normal condition. Then as the temperature increases, even the pressure also increases. So there is always a risk of explosion. For this, there is a pressure valve that is been built within, so that some of the vapor will be slowly escaping from that. Since the temperature is more, the food gets cooked very fast compared to that of the ordinary pot. So let's do one sample problem on Gay-Lussac's law. A sample of nitrogen gas has a pressure of 6.58 kilopascal at 539 Kelvin. If the volume doesn't change, what will be the pressure be at 217 Kelvin? So in this, the step 1 is known data, P1, T1 and T2. T1 and T2 are in Kelvin, and unknown is P2. So step 2 is figure it out what gas law should be applied. Since volume is constant, we can easily say that we should follow the Gay-Lussac's law. P1 by T1 is equal to P2 by T2. But since P2 has got the T2 also, so to rearrange the formula to figure it out the unknown variable P2, we need to cancel T2 by multiplying T2 on both sides. So in that scenario, we get the formula P2 is equal to P1 T2 by T1. So plug in the known data to solve P2. So we do get 2.65 kilopascal. So if you see and check the analysis of this one, as the P1 is 6.58 and T1 is 539K to 217, it has decreased. So since these two are directly proportional, then even 6.58 kilopascal reduced to 2.65 kilopascal. So that indicates that we did the. Okay guys, now it's time for the checkpoint. Try to read the problem and solve it by using the Gay-Lussac's law. Finally, watch this video link for Gay-Lussac's law's experiment. And that's it guys. See you in the next video.